All right, let's continue on with investigating quadratics in chapter 8. So this is right after 8.3, the quadratic formula. So what we're going to do here is we are going to go to this page, name, all right, and this is investigating y equals ax squared and y equals ax squared plus c. So what I need you guys to do is get out your calculator. So here's mine. And what we're going to do is we are going to graph these three equations here, okay? So first thing I'm going to do is clear this out. All right, now I'm going to type in x squared. And I'm going to do these one at a time just so you can see what they look like. So I hit graph. So this is y equals x squared. So if I go down and now I type in y equals 4x squared, I'm trying to figure out what does this number in front do to the parent function x squared. So now let me graph that. So we have y equals x squared right here, and this is y equals 4x squared. So what appears to have happened here is this number in front has seemed to narrow my graph. It kind of, I guess for lack of a better term, squished it, pulled it closer to the y-axis. Okay, now let's see what does this 1/4 do. And if my conjecture is correct, if 4 made it closer, 1/4 should make it further away. So I'm going to clear out the 4x squared, and I'm going to put in 1/4 into this. So 1 divided by 4, and then x squared. And I'm going to leave that x squared parent function in there just so we can see what happens. So here is the x squared, and here is the 1/4 x squared. So notice it is wider. So this number out in front, okay, this number out in front, okay, controls the width of my function. Okay, so the graph of, all right, now let's see if I can get this in here for you. Okay, so let me put this in. So right here, the narrowest would be y equals x, or 4x squared. Okay, now you'll have to apologize or forgive me for not having a math editor, but we can't have a math editor, and I can't show you my calculator and type the notes in, so I have to do it this way. So here we go. Now the narrowest one was y equals 4x squared, and the widest one would be y equals 1/4 x squared. Okay? So there's those two. Now what I want you to do is I want you to kind of do these on your own. Tape it on your graphing calculator, plug it in, okay? If you have different colors, it's going to help you out here. So when you do that, make a conjecture before doing the problem. See which one's going to be the widest, see which one's going to be the narrowest, okay? So I'm going to give you a second to do that. All right, so the narrowest one would be y equals 2x squared, and the widest one would be y equals 1/2 x squared. Okay, so the conjecture is based on the graph that you analyzed. Okay, in sections 1 and 2. Okay, what is the relationship between the number out in front of the x and the wideness of the parabola? Well, A, as we like to call it, all right, A controls the width of the parabola, okay? And A is this number out here in front of the x squared. So up here in our problems, this number controlled the width, and so did this one. This one and this one did. The larger, okay, the larger A is, it narrows my graph. All right. The smaller A is, widens my graph. Okay. So here, graph the following equation on the same screen. All right, sketch them. Okay. Now we have 6. So which one's wider? Okay. So by what we just talked about, this one would be wider because it is larger. Okay. So what happens in this one? Okay, we have y equals, all right, let me get this for you. Y equals 6x squared. Okay. And let me get rid of this guy for you. So notice that's right there. Now, what happens if I do negative 6x squared? And I'm going to put these on the same screen so you can see it. So not only does A control the width of my graph, but it also controls the direction. A also controls if it opens up or down. Up is positive and down is negative. So here, they're both the same width, but this opens up because it's positive, and this one opens down because it's negative. So if the A value is positive, okay, well, apparently there, okay, here we go, try this again. Okay, if the A value is positive, the parabola opens up. And if it is negative, as you guessed it, it would open down. Okay, so graph the equations on the screen, all right, and write the coordinates of the vertex, okay? So let's do y equals x squared plus 1. Remember, vertex is going to be the bottom or the top of my u. So x squared, I believe it was, plus 1. Okay. So I'm going to graph this. Here we go. So this is the bottom of my u. So I can move my cursor up. All right, right there looks to be the bottom. Let's see if I can trace it. There we go. That is the bottom, 0 and 1. So my coordinates right here, okay, would be, the coordinates of my vertex would be 0, 1. Okay, what about this one? Let's see what that one would be. So that was y equals x squared minus 2. So that one's right there. So let me see if I can graph that. 0, negative 2. Anybody want to take a guess at what this one would be? I know. Nicely done, Garrett. It would be 0, negative 4. And as you kind of figured out by now, this would be 0, 5. Now these are actually in vertex form. We talked about that earlier, I believe, back in the completing the square. Where did that go? I'll show it to you. Okay, back here, when we completed the square, all right, all the way back here, and these were in vertex form, okay? And I'll talk more about vertex form later on. Okay? But vertex form is very useful in figuring out the max or the min. But in here, we're using the calculator to figure it out. All right, so let me get rid of this. So compare the vertices of each graph and make a conjecture. Okay, so this number outside, okay, this number outside actually did something pretty cool. What it did was it shifted my graph up or down. So this C value shifts your graph up or down, okay? So it shifts it up if it's positive and down if it's negative, okay? So we can change the appearance of the graph by altering its scale on the Windows screen, okay? So y equals negative 2x squared plus 1. So let's see what's going on with this problem. So y equals negative 2x squared, right? Plus 1. Okay, so before I even graph it, I know because this value is negative, it's opening down. It's a little narrower than an x squared. And this shifted that bottom, that vertex, up 1 unit. Okay, so I graph it. Here we go. It says, describe how the graph looks. Okay, well, I think the graph is in the window just fine. There's no need for me to mess around with that. But if it was out of the window or shifted somehow, I can change my window, okay, by clicking window. Maybe I want it to, say I want my y max, okay, so down here, my y value, maybe I want that to be, say 2 is my y max, okay? So now you can see, I can see more of the graph, it's opening down, I can interpret a lot more about what's going on down here. But this is like an opinion. Are you able to gather the information you need from your graph? Okay, if not, you can play around with the window. Okay, it's right here. You can change your y min, y max, what you're counting by, all those things like that. Okay, so if I wanted to, okay, down below, we talked about it, I could change my x min to -5. All right, I could change my y max to 5. I could count by 0.5. Okay, and then for the y, so maybe I want to count on the y's by 2, and I want to go all the way down to -20. So I can do all of this. Okay, now you can see when I graph it, it looks a little different. Okay, so it's all about your opinion. All right, if you have any questions about just, what does A or what does C do to your graph, just let me know. Remember, the whole point of this is A controls the width of your graph, and it controls which direction it's opening, up or down. And C controls whether you're shifting up or down with that vertex. If you guys have any questions, reach out to me. I'm here to help.